Hello? 1, 2, 3. You guys hear me? Great, because I don't hear myself. Anyway, hello everyone who made it here. My name is Mark Sterin. I'm an engineer in the storage division. I'm going to do a quick talk about the storage for Kubernetes. A couple of years ago, the people were saying, hey, all our containers are mainly stateless, so we'll take care about the storage somewhere else. And that always reminded me of this, say, hey, there is a problem with storage, but thanks God it's not my problem. The latest data from whoever, this is specifically from Datadog, this is specific online, lots of people are running the online containers there, show that like 6 out of 10, if I'm not mistaken, off top, container images are actually storage-related, database, SQL, NoSQL-related apps. So that's why we introduced the persistent storage for Kubernetes and for Docker with the project Hatchway. It's a nice name, but it basically, what we wanted to do is we wanted to get easy access to vSphere persistent storage for containers running in any orchestration system, in Docker Swarm, and Kubernetes, whatever. We wanted it to use everything from vSphere storage, so you are not limited at all. We wanted it to be natively integrated, so there's no really new concepts to learn because it's whatever you know from vSphere plus whatever you know in Kubernetes, and zero configuration. Zero configuration is a little easier when it's natively built in Kubernetes, and in Docker it's nice music, I guess, sorry. And in Docker it's a little bit more complex because Docker is a little bit more hesitant of putting things in the Moby code base. So we have two components, both of them are around, both of them are open source. One of them is vSphere cloud provider. It is a part of Kubernetes, so if you have Kubernetes installed, you have it. The second one is Docker volume, vSphere storage for Docker, or Docker volume services. Also open source project around there for a while. Works with Swarm perfectly fine. The key thing there is just take the storage from vSphere that you know about and natively and seamlessly integrate it with Kubernetes or Swarm. I'm going to be talking about Kubernetes. And in Kubernetes, you inherit lots of things, like, for example, scalable deploy of stateful apps and the rest. I have a nice diagram there, but I'll move on. So that's generally how we see the whole story. You have the basic infrastructure, you have the VMware with the NSX and vSAN and what's not. You have the Docker Swarm or Kubernetes on the top of that with all the commands involved. And we just want to add those two things. We really want to be, for you in Kubernetes universe, to just say, hey, create volume, vSphere, point to your policy and be done with that. And in Kubernetes, we wanted to say, hey, this is my policy, those are property of my storage from vSphere, just use them. And that's exactly what we did. It's publicly available. So there are two parts to that. As you saw in the prior presentation, if you've been there, the whole thing is built around, in Kubernetes, everything is built around persistent volume, which is a representation of the actual storage, and persistent volume claim, which is a request to get you the actual storage. And there are two basic ways to do that. The first one is static, which means, as was presented, an admin creates a bunch of storage, VMDKs, essentially on vSphere, and says, okay, those are VMDKs, those are the persistent volumes. And then somebody else like developer is asking, hey, yeah, sorry, a little bit ahead of myself. Somebody else, developer, is coming in and saying, hey, I want this amount of storage. And Kubernetes goes in the pool with volumes, find the volume that matches the size, and binds it to your claim, and then application has the storage. And if you delete things, you have to do the same. You delete the claim, and it goes back to the pool, and somebody has to remove it from the pool. So in a statically provisioned universe, that's what's happening. You have to provide a bunch of VMDK. You have to create a few files saying, okay, these VMDKs are those, have these names as persistent volumes, and then leave it to the developers or the application deployers to define the claims. This is a kind of real old, so my point here is that, yeah, if you guys have some use case that will actually need that, as opposite to dynamic provisioning, I would really love to hear about that, but that's my view. So, this is what's happening with the dynamic storage, with dynamic provisioning. With dynamic provisioning, the admin, who is this small figure on the left, basically describes of how his existing storage policies map to what Kubernetes call storage classes. That's pretty much it. You just have to say, hey, I want to expose these policies as those storage classes. And then somebody, application developer, application deployer who needs to deploy, pretty much puts the claim, creates the claim, persistent volume claim saying, hey, I want this amount of storage of this type and can specify additional things. So those are the steps. You define storage policies in vCentral, which I assume you already have, or you use, like for example, vSAN built-in policies, so you don't define anything. You define storage class YAML, I'll show that, and you define persistent volume claim, you meaning in the last case a developer, most likely. So before that, as a really quick plug, if you already have Kubernetes, great, you have everything installed. If you just want to play with Kubernetes, there are many ways to develop, to do that. One of them is Kubernetes Anywhere, which is the green thingy there. It's a tool which also helps to develop. You run a Docker container with the Kubernetes Anywhere, and you say make deploy. It asks you a bunch of questions about where to place Kubernetes, how many nodes, blah, blah, blah. Deploys it, configures cloud provider, configures storage, and moves on. Another approach is Kuba, which is the part of just announced pivotal Kubernetes services, Kuba 06, and you had some demos, I think, even on the keynotes, and Kuba 06 already has integration with cloud provider as well, so if you deploy it using Kuba, you have everything configured, or some other methods. Moving on. So defining storage policy. First of all, you just define the storage policy in VC. And you name it whatever. I name it gold because everyone names them gold. The second thing is, yeah, just put literally, this is the file. This is the file that says, I want a storage class which is really representing vSphere storage policy gold. And just let's name it MiniOSC because that was for the Minio demo. That's literally it. And you just do kubectl create -f, you pass this file, and Kubernetes creates all the internal structure needed. Then somebody needs to define and wants to use the storage, so they say, hey, I want to use the storage. And there are two cases. The first case is that you know how much storage you need. You need 3 volumes, 20 terabytes each, whatever, of this policy. And that's it. And then you define the claim, and the claim says, hey, I want to use this class. That's how you connect it to actual vSphere storage. And the rest is obvious here, how many gigabytes and your names to connect it back to Kubernetes. But that's about it. Another case is that when you want to scale up your application, you don't know how many replicas of your apps you're going to be running. Maybe you want to have 50 Couchbase nodes or 20 Couchbase nodes. And you can tell Kubernetes actually, hey, I want an individual storage dedicated to each node. And that's, in that case, you use stateful sets. And to the stateful set, you tell which storage you need using the same thing. You just pretty much say, hey, use the vSphere cloud provider and use the Couchbase storage class. That's all configuration from the person who deploys it. Then what happens next? I think I'm actually, anyway, what happens next? Somebody goes and creates all this object in Kubernetes API server, as was described in the prior review. And again, that's for my demo, which I didn't run here because I need some different hardware. And it creates a bunch of objects inside of Kubernetes. But then Kubernetes actually goes back to vSphere cloud provider, to the code that talks to the VC, and asks to create provision volumes. So in this specific case, I deployed my Couchbase with 2 nodes, with 2 server nodes. So it asks for 2 volumes. And you can observe it in the VC because you'll see different tasks that we are submitting back to the VC, you know, create disk, attach disk, detach disk, call this manipulation. Then the result is that we're going to give Kubernetes the fully prepared and attached VMDK, which Kubernetes will format, mount inside of the containers, and then your application will essentially have the storage of the type and of the size you want. And that is the example of especially in application, how you just point to the storage. Whoever writes the app just says, hey, I want this opt Couchbase var. It goes from the Couchbase data, and that links back to the storage provider. So really what I wanted to emphasize in this 10-15 minutes walk through is everything you know about vSphere storage stays. You define it the way you define it today. Everything you know about Kubernetes stays. The only thing you have to do there is to literally create the storage class saying, this is my policies in vSphere, and this is my name in Kubernetes. And then you use standard Kubernetes claim system to say, use the storage. As Kubernetes creates replicas of your app, scales up, scales down, or just provisions, it will go to VCP to us and ask for the storage. We go create VMDK in the proper policy. We attach it to the proper node, properly formatted, and then Kubernetes mounts it inside of the container. Kubernetes 165 has it. Kubernetes 174 has all the latest, but it has some performance implication and bugs. So if you want to play that with that, I personally recommend using 175, which is due in a couple of days. For more info, you can go here. And I think I'm 2 minutes ahead of time. So thank you very much.